Alright, you want me to explain particle-wave duality as it applies to quantum field theory. So I'm going to stick with the same metaphor. Imagine like a lake or like the ocean or something. Throwing that rock into that body of water creates a wave. And like I said in the previous video, all things are just waves in quantum fields. Now imagine this problem. Imagine if I asked you to point to one and only one point where that wave is. You couldn't really. The wave is radiating out everywhere. But you could kind of point to the center where the wave was highest and go, I guess it's there. It's not entirely accurate to say that the whole wave is right there in the center where it started, but it's accurate enough to describe the location of the wave. That is a particle. That is a discrete location of a thing. The problem is the more you know where something is, the less you know about how it's traveling and where it's going. You might know this as Heisenberg's uncertainty principle. And that's really just a function of how we are looking at this wave. If we look at just the center and say, there, the wave is there, then we don't get to see the ripples emanating outwards, so we don't know how big those ripples are or how fast they're moving. If you zoom out, you can see the ripples and how fast they're moving and get that information, but now you are looking at more than just the center. So where the wave can be is everywhere you're looking, so you know less about its location. And when you zoom out like a lot to the universe, then you just see a ton of waves interacting with a ton of other waves. Just waves in quantum fields as far as the eye can see. But eventually we have to ask, where is this thing? Like, we can't just say it's everywhere where the wave is, we have to ask where it is. And so we say it is most likely where the wave is most pronounced. Hence, if you get a really pronounced excitation in a quantum field, we call that a particle, even though the excitation itself is just a wave like anything else. Hence, particle-wave duality.